Hello everybody, welcome back. Today we'll be working on another machine learning project called Movies Recommendation System. So in today's era, you go anywhere, you type on YouTube of machine learning projects and you will be recommended with this channel, this video in the channel. You go on Netflix, you type for some particular movie and Netflix will show you 100 more movies that are having sharing the same genres or have similar titles. So this project has similar aims. So let's head back to my computer screen and we'll see how the project goes. Alright everybody, so we are on my screen. Let's start working on the project. So this is my movies recommendation system so far. I've already pre-written the code again to save time and explain all the codings. So if you see here on my Jupyter panel, you'll see on desktop I've created a movies, like a folder named movies, and here are all my files situated. So if you see here, you have the IPynb checkpoints saved and you have the main file. So I've named my Jupyter notebook main. You can name it whatever you want for now. And starting with the ML project, as you know, Kaggle is our go-to place, the hub for datasets. So you can go on Kaggle, search for any specific movie dataset if you want. But then so far Tmdb movie datasets is something that mostly ML developers have used. So you can go ahead over here. I'll also provide the link in my description so you can download it from there. And I have already downloaded. You can see my dataset.csv file already present on the folder. So first of all, we can go ahead and use the code movies is pd.read to read our CSV file. And then you can simply type in movies.head. So you can check out, you can take the top 10 dataset list from the data. You can also check out just 5 if you want. So you have your ID, your title column, overview, genre, and tags. Yeah, so that's all we have so far. So we'll be refining the data further so that we can easily use it for a recommendation model. Now, further what I have done is I have used movies.describe. So to basically describe the data and we can get more info out of it. So we have the count of IDs, we have popularity of the movies, then we have vote average and vote count. All the mean, standard deviation, 25%, 50% is there. So that way you can analyze your data. Next we have movies.info. So you are taking out info from the dataset. So you have your ID data type, your title data type, genre, and all those information is present here. You can see the data type float64, and we have integer objects, all sort of data types. Okay, next what I've done is movies is null. So basically I'm checking if there are any null values in our data. It's a small data, relatively, I think 10,000 entries. So it's necessary for us to check out if there are null values. So you can see here in genre you have 3 null values. In overview you have 13 null values. Rest assured, I think is fine. Yeah. Next, what I've done is I've checked out all the columns. So basically, if you know what all columns are there in your data set, it's easier for you to analyze it. And then we can figure out what kind of columns we need to further refine it and then use it in our data set. So we have ID, titles, your genre, original language, okay, overview, popularity, release date, vote average, and vote count, with all data types being objects. So I think we won't need all of these columns. We'll just need ID, title, maybe your your genre, could be popularity. So exactly. So like I mentioned, we don't need all these columns. For example, this original language, etc., is not really necessary. So what I'm doing is I'm giving movies as a variable, and what I'm doing is setting movies as a variable, and we're only keeping ID, title, overview, and genre. So these are the only columns we'll be working with further. So we don't need the non-necessary columns right now. So again, since I kept movies as my variable, I'm hitting movies and then I can see all the data here. So it will basically display me the top 5 and the last 5 data columns. So you have your ID followed by title, overview, and your genre. So you have drama, crime, comedy, drama, romance, all these kinds of history, all kinds of genre we have. And we have titles and the ID followed by that. So if you see here, yeah, right. So it will display how many rows and columns. So we have 4 columns that we have kept, and we have 10,000 rows. So we have 10,000 movies approx in the data sets. Now, let's go ahead, and what I've done here is movies tags. So we need to add the tags column in order to perform operations further on the data. So I've added I've added tags here. So you'll see beside the genre, you'll see the tags that have been added. So that way you can see like what all movies are like similar to each other according to their tags. So yeah, again you can see a extra column is added. Now what I'm doing is I'm removing overview and genre here. Could be because later I found out that overview and genre wasn't helping out in finding out the similarity of the movie, and if they were unnecessary, I've removed it. So I've removed here new data. I've set a new variable named new data, and I've dropped the columns. So you can use movies.drop, and you just have to name your columns. So for example, I've named overview and genre, so that will be removed. And now once I hit new data, it will show me the new data set, whatever is present. So again, top 5 and last 5 columns are shown with ID, title, and tags. So this is the refined data set we have right now. Very simple. So far, we just removed all the unnecessary columns we had and refined the data with just limiting with just 3 columns. And this is what we'll be using to then find out the similarity between our data set or same movies. So now we have 10,000 rows by 3 columns. Now, what we'll be doing is, since we have the refined data set with us now, so we need something so we can use this data set to later train our models and then find out similarity and display it to the end user. So we are using the sklearn or scikit-learn, as you wish to call it. We are using that library, and what we are doing is we are importing count vectorizer. So what count vectorizer will do is all these data, it will like enumerate it into a data that is readable to the machine language. So again, I have set CV as my variable next, and initialized count vectorizer. And for max features, since we have 10,000 data set, I have given the 10,000 value. And I'm also using stop words English because then since we had a column with the original language of the movie, so we might have movies with non-English languages. So I'm using stop words English so that we only get English language movies. Again, when I hit CV, since it was the variable declared, you will get counter vectorizer that shows your max features are 10,000 and stop words are English, right? Now, in the next step, what I have done is I used vector equals to cv.fit transform. So I'm transforming the new data that we have now. And since we are using tags column, so what I'm doing is I'm converting the tags column data into UTS. So then you use values as type, and for now you can just use u and to array. So then when you hit on vector shape, so when you hit on vector shape, you'll get 10,000 by 10,000. All your data set has been now reformed in the vector shape. And in the next step, what I have used is again I have used scikit-learn, and I have used pairwise. So basically, what I'm doing is I'm importing cosine similarity. For those of you who do not know what is cosine similarity, you can either research on it, or if I have to explain you in simple terms. So it's basically when you vectorize, when you have to find out similar stuff in a movie data set and imagine it in a vector form. So for example, let's say you are comparing 2 different objects or 2 different things. Let's compare 2 animals. We are comparing lion and a tiger. So then when you when you put it, so when you're comparing 2 different objects or 2 different things, for example, if you're comparing a lion and a tiger, then we'll jot down what are the tags or what are the definitions of what is a lion, what is a tiger, and then we'll draw vector lines from there, from the origin to and then we'll end it somewhere. Metric helpful. Okay, so in the next step, from sklearn.metrics pairwise, I have imported cosine similarity, which is a very crucial step here in our dataset. So what cosine similarity is, if I have to explain you in very simple terms, cosine similarity is something when you're comparing 2 different objects, it acts as a matrix unit of calculating what is the similarity between the data. And irrespective of how big your data set is, it will help you find out the similarity between the data. For example, let's take a very simple example. You're finding out the difference between a lion and a tiger. So you start with a metric unit that starts from the center, and then you take the vector from the center to somewhere in the air, and then you calculate the angle between the vectors. So if the angle is small, their similarity is high. If there's a large angle, then the similarity is low. As simple as that. And when the angles are very small, that means if they're overlapping, right? Your theta is overlapping. Then you can say that those two objects that we are comparing, or those two things we are comparing, are similar. Now you can go ahead on Google and you can easily find out, you can deeply research on what cosine similarity is, and it's purely mathematics. You will see how. So like I was talking, right? It's vector. So you have a theta between y and x, and the smaller the value of theta, or more the overlapping value of the theta, the more the similar objects that you are comparing. So you can go ahead and read more about that if you are curious about what cosine similarity is. It's just basically a metric unit that we're using to find out the similarity between the movie data set. Okay. Now, in the next row, similarity cosine, we are using vector. And when you type in when you're typing similarity, then you get displayed this. And you will always observe in your array, right? You will always see your diagonal elements, or your diagonal values are always 1. What 1 represents is that these data sets are similar to each other. Now, what I'm doing is I'm taking the new data that we have, and from there I'm comparing index with title. So at index 0, we have title Godfather. So if you hit on that, you get 2. So on your data, you will see here. So you will see at index so and so with this ID, or maybe at index 2, we will be having Godfather. That is what it is representing to us, right? So then using this index value, we'll later figure out, like, if the user has given us movie name, then the data set will figure out what index value the title is, and then through that index value, we'll be able to figure out what other titles are, what other movies with specific titles are similar to that movie. I hope I explained it better. So in the next step, what I have done is distance is sorted list. So I'm enumerating the similarity between two objects. Again, I'm using index 2. I'm using ID 2, which we saw earlier for the Godfather movie. And I'm using reverse value true. So basically, we're just using index to figure out what's the similarity between two objects or two movies. In the next step, what I'm doing is I'm using distance sorted list enumeration. So basically, I'm enumerating similarity on index 2 again. So Python index basically starts from 0, and we are using index 2 here. Now, what I'm doing is reverse true key lambda vector 1. So what basically this does is we are using similarity over here. So basically it goes through all the data sets, finds out what are the similar data, and what sorted list does is, sorted list enumeration does is, so it basically converts all that list of data into tuples, and then sorted list, what it does is it works as a loop. So here, if you see for I in distance 0 colon 5, so we will be creating a loop of tuples. So every 5 tuples will be went again and again, and then find out what similar kind of data sets are present, and then with print new data title, so we'll be displaying the titles that are similar to index value 2. So here in the output, you can see index value 2, we have the Godfather, and then it will convert that dataset into list of tuples, and then that tuple will be revised in order to look out which movie titles are similar to The Godfather, which is present on index 2. And you can see the output shows all the movies similar to The Godfather. We have The Godfather Part 2, Blood Ties, Joker, and Bomb City. So these are the recommended movies. So now we can figure out that our MN project is working fine. We can recommend movies based on the titles. Right. In the next step, what we are doing is def recommend movies. So I think I've butchered the spelling of recommend. Apologies for that if I have. So what this code basically does is I'm defining a function called recommend. It is supposed to be recommend. I've butchered the spelling. Apologies for that. So now we are defined a function called recommend movies. So what this will do is, again, it will the further code will go through all the list and go through the index number provided. It will match what index numbers in the list are similar to each other, unlike just like the above board, it will go ahead, look at the sorted tuple list, and whatever value is similar to each other, it will go ahead and it will go ahead and print the title. So if you so after this, if you now use recommend, again apologies for the blunder in the spelling. Again, if you use recommend and you write your movie name, so Iron Man is one of the movies in the list. If you use that function, so it will again recommend you 5 movies that are similar to that. If you go ahead and change the movie name, right? If you write something like, if you write Batman Begins, I hope that is present in the movie list. Yeah. So if you hit on Batman Begins, it will give us the movies related to that. So we have Batman, The Dark Knight Returns, we have Bad Blood, etc. Joker, of course. So the recommendation is working just fine now, and the function as well is working fine. I can change the spelling here, but then it will affect our app.py code. So let's just keep it like that. Later, I have just simply imported pickle. Now we are using pickle to save our model. So far we have done with the training and whatever the refining of the model we had to do. We imported just to summarize it, we imported and read our CSV file. We saw what all data is present here. We had to refine it. We took the information out, described it, used the info, removed the null values. Basically just removed the entire column. So there was no need to remove the null values. And we checked out how many columns we had, only imported whatever columns are necessary. So we ended up with just 3, which is ID, title, and tags. Later, we used sklearn library to then remove out the English acronyms, like we just use English movies. Then we refined it further. We used the cosine similarity, which was the very most important part here, I assume, which was the most important part here. Yeah, right. So we define the function recommend. So that is when if the user hits their suggest or recommend whatever button he hits, that is when the user should be recommended the movies based on whatever title they have given. Next, finally, we are importing pickle. We are using pickle dump to load our new data, to save our new data. So I am saving our movies list as a PKL with right binary. And I'm also saving similarity. So we have to save our movie titles as well as the similarity model we have developed that will be doing whatever the similarity checks are there in the backend. So we have right binary in similarity and our movies list file. Then we are loading it here. So we can just have a final look here. So you can see again, we have our index, we have IDs, we have titles, and we have tags, right? 3 columns, 10,000 rows. That is all for the machine learning model. It was fairly simple and smaller than the previous one. Now let us go on our Visual Studios and we'll see what the app.py code is. Alright, we are on my second screen and let's move forward on the progress of our project. So now we just need to use our VS Code and then we'll create some more files. So you see checkpoints are there. We have our data set. What's it? We have checkpoints, we have data set. The main file is from our Jupyter Notebook. Then we have another main file from VS Code, but I don't think even if you don't have this, it's fine because I've just imported my dataset. I was just looking at how the dataset looks. So it's just importing pandas and I've just read the CSV file and I've printed the data here. I was just looking at the dataset that we have imported. Next, we have movies list.tkl and similarity.tkl, which is what we downloaded, we downloaded using the pickle from our Jupyter Notebook. Next, I have a README file for my GitHub when I'm putting this on GitHub. So let's go ahead on VS Code, or we could just open it as it is. But we'll just go on VS and open our folder. So I'll go to desktop and I'll look for movies. Right. So we have this right here. I'm selecting this folder. Right. So all our files are displayed here. Now, the only important file we have here is app.py. That is all necessary right now. I'll close the terminal. Okay, this is a fairly small and easy to understand code. I'll make you go through it very easily. First of all, we have obviously imported our Streamlit library, Streamlit as ST. Next, we have imported pickle for our data sets, and we have imported requests. It is, VS already gives you the description over here. So request is basically just in order to get fetch HTTP request from the internet, because here we are further in the code, right in the second block of the code, we can see we are fetching posters for movies, because obviously when we are using the front end, right? So we need to show the user the movie posters in order for him to understand which movie it is. So we are basically fetching posters from this URL and provide the entire code in my description, so you will also get access to this link, which will basically give you all the movie posters. Right. Apart from that, we are fetching it through movie ID. Okay. Next, in the next block, what we are doing is again from movie, we are keeping movie as the variable. We are using pickle to load two of our data sets, which we just saved, which is movies list and similarity.pkl with read binary, and with movie list title. So from title, we'll be using title as values. Now from use st.header, so that basically whatever you type in st.header will be the header in your web API. So movies recommender system is what I'm keeping, which will be the display heading in my web API. I can change it to whatever I want. We can also keep it, if not recommender, let's keep it let's keep it movie recommendation system. So that will be displayed there. You can keep whatever you want. Now, what I'm doing here is I'm creating a drop-down list, as I have commented already. So when a user will be shown your fetched movie posters, below that, the user must be having a drop-down box from where he can either type in or choose from the list of movies. Okay, so selected movies, and you will have st select box and select a movie from your movies list, obviously from your data set. Now, I again imported Streamlit components. These are just the components you will need in your web API. We were as components, right? Now, I'm using that function we created in Jupyter Notebook, which was recommend. So here I am not butchered the spelling, I guess. So I'm using def recommend movie. Again, I'm bringing that function back here, and we are using the same enumeration list. We are sorting it up on list and then going through whatever recommended index is fine. Okay, and yeah, so like I said, if you have research on what cosine similarity is, you will need distance of the vector. Now we are appending, and then again, so when we're done with the similarity check, we will need to append our fetched movie poster. So when the list of 5 movies is displayed, you also have the posters displayed along with it. Okay. Again, lastly, we just have the button displayed here. So if st.button show recommend, you can again customize your button, whatever you want the button to display. I am having show recommend, or I could remove the show. I can just keep recommend. So when a user hits on the button named recommend, the 5 posters as well as the movie name will be displayed here. So you can see st text movie name, and you can see st image movie poster. So all the 5 posters and your text will be displayed. Fairly simple code. We are just using Streamlit to deploy our web API on our local server. So now, hopefully you have understood the code so far. You can just recap the video if you haven't, or of course I'll provide the code in the description so you can go through it for yourself. So I'll go ahead and get a new terminal for me. Okay, so the terminal is open. Earlier, if you have seen my video where we used Flask, right? So we use Python app.py to run our Flask app. Here for Streamlit, you just have to use Streamlit run, and you just have to give your file name. In this case, it is again app.py. If it was main, I would have written main.py. So again, Streamlit run app.py. As soon as you hit enter, your local server will be launched and you will be redirected there. So you see we are running on localhost 8501 server, 8501 port, my bad. So you already have a movie name, The Shawshank Redemption. I can either select from the drop down, or if I want, I can go ahead and type my own movie name. If I want The Avengers, yeah, we have it here. If I want to go for the Avengers and I hit on show recommend, it will go ahead and recommend. So it was running here and you will see the Avengers. So you have Consultant Kingsman, Matrix, you have Alien, Human Bureau. Alright, if I want some other movies like we saw earlier, if we want Batman, and I hit on Batman, I hit show recommend. So it will recommend those movies. So we have Batman Returns, we have Batman vs. Dracula, The Joker, all those movies, right? Oh, Batman Beyond, okay, Dark Knight Rises. Right, so the recommendation system works fine so far. You can either type in, the user can either type in or choose from the drop down. Yeah, that is the end of our project. Hope everything was clear. Once again, everybody, I think I missed explaining quite a crucial part of the video. So let's head back to our amp.py code. Here, if you see this section of the code, right, where we are basically fetching our posters, our API for launching it in the browser, that part needs quite a brief explanation, which I have missed. So let's head back to this section. If you remove this section, right, fetching the posters, all we can see is our model will be working in the backend, will get the recommended movies, but then we'll only get the titles that we are fetching from like our movies list and similarity.pkn files, and we'll just get the titles recommended, but the actual movie posters or the graphics content you see on the browser, right, all that has to be fetched. So for that, you'll have to go and open your Tmdb site. Just go and hit your Tmdb site and you'll have to log in there. Once you log in, once you have an account of your own, it will look something like this. So over here, go to API, go to more and look for APIs. So when you look for API, what API will do is it basically says you are using content from Tmdb, right? So what API will help you is, it will help you link their used content which you are using, like their movie posters you are using. It will help it link their content with ours. For example, our ML project has a job to recommend 5 movie posters to the user who is clicking on what recommended movie he wants. And what this API will do is it will connect your model's output with their content. For example, when you are hitting on particular movie and you get 5 recommended movies, then the job of API is to launch the display the 5 posters of those titles. So then here, like I said, when you are in the API section, you will have a create option. Just go to developer or professional according to your needs, and I'm clicking on developer. I'm accepting their terms, and here you will see an entire application. You will have to specify what is your use, either it's desktop application, mobile application. In our case, we have a site. You have to give your application name, which then your URL. So for application name can be subjective. You can keep it whatever is your liking. You can give a summary. You have to fill in all these details and then submit this in order to get an API. So from Tmdb, once you get your API key, right, when you get your URL, so it will look something like this, which we have already used in our code. You can see it here. After submitting all that report, all that formal things. So once you get this link, you can use it, just copy paste it here in the code. And next you can see here we have used a full path, right? It's something like https image.tmdb.org. So this full path is basically what is fetching our poster images. So for this, in order to get this right, you will need to hop on to this site called Postman. So hit postman.co on your Google browser and you will be redirected here. You would have an overview tab. When you open it, just hit on this plus icon, you will get an untitled request tab open. Here you just we need a get request, right? So you keep it to get over here, and then you paste your URL over here. And when you, for example, so we have this URL, so I'll just copy it from here. So once you copy it and just paste it here, and when you hit on send, you will get your response as a code. From there, you will get this URL, which we are using it here. So this URL is basically helping you to fetch out the posters. So that's all in this segment, which I actually, which is quite a crucial part, which I forgot mentioning. So if you remove this section, like I mentioned earlier, you won't be getting all those posters, all the graphic things. So this is quite a crucial step. I hope I'll also provide this link in my code as well as in the description, so it is easy for you guys to apply. And rest all assured is exactly what I mentioned earlier. That's all. Thank you so much. If you have any queries, you can either comment it down or you can email me or reach out on LinkedIn or whatever place you find preferable. Thank you so much.